Alright, cool. We're going to look at this new puzzle here and apply our 30, 60, 90 triangles to the puzzle we're looking at right here. So, first thing I'm going to do, let's go ahead and take a look at all the angles inside of these triangles and see what we can learn. I've got 30 and 90. Again, 180 minus 90 is 90 minus 30. That's going to leave me with 60 degrees. So that's got to be 60 degrees right there. Also, I know that on a line, we have 180 degrees. So let's do 180 minus 60, 120 minus 60 again. And looks like that one's going to have to be 60 degrees right there. All right. Well, hey, look at that. I got vertical angles right there, which means this guy is 90. And if that's 60, this guy's going to have to be 30, because that's the only other angle that's going to add up to 180 degrees. And similarly, these guys are sharing a line as well as these. That has to be 90, and this is 90 as well. And that means that this guy has to be 60. Well, wait, can I prove that? Let's double check. This guy here is 90, all right? I know that it has to be also because I've got these two guys being parallel along with this one too. So if these guys are both 30 and these guys are parallel, this guy's perpendicular, all right, meaning that it goes at an exact 90-degree angle to two parallel lines or any line, then these guys are going to add up to 60. 90 minus 60 is 30. All right, cool. So I know that that guy's got to be 30 as well. All right. So if that's 30, this now has to be 60, and if this is 60, this guy up here is going to be 60. How do I know that? These two guys are parallel lines, so this transversal, all right, or the line that's crossing through these two parallel lines right here is going to leave me with the same angle, all right? Imagine a bullet kind of coming through. It's going to come in and leave over a short distance at the exact same angle that it came in at. So these guys are both 60 degrees, if you can think about it like that. You can kind of almost see like their vertical angles, but that would be if this guy was extended over. So don't worry about that. I do know that that's 90 though, because again, these guys were parallel, and if this is a 90-degree angle here, that has to be as well, leaving me with another 30-degree angle up there. Wow, look at my luck. All of these 30, 60, 90-degree triangles. So that also means that all of these triangles are similar, and we can apply the same rule that we just talked about to all of these triangles. So let's do the ones that we can see and know the answers to, like this guy right here. That's 3, which means that this guy's going to have to be 6. And again, this one may be a dissatisfying, but at least it's complete, 3 root 3. Which also means that this guy right here has got to be 3 root 3. Cool. And that's shared between these two triangles. If this is a 30, 60, 90 triangle right there, and that's 3 root 3, that means the only thing that this guy can be is 3, and this guy is 6. How about that? Cool. You can also kind of see here that these guys all look like they're exactly the same size. That means that these are all congruent triangles. All right, that means that if I were to cut one of these guys out, it would perfectly overlay on top of one of these other ones. But I also have a couple other 30, 60, 90 triangles that are popping here. One you notice here, that's 60, so this little piece here has got to be 30, and that means that this guy's got to be 60. So I've got this 30, 60, 90 triangle right there, and I've also got another larger 30, 60, 90 triangle in addition. So that actually is going to help me out a little bit when I'm trying to solve out the rest of these, especially on this very small piece right here that's going to be otherwise pretty tricky to figure out. All right, so this guy is going to be 2. That means that this guy is 4, and that means that this guy is going to be 2 root 3. All right. That also means that if this guy right here, that's 3 root 3 and that's 6, this guy's got to be 3, even if we don't know it. That's definitely 3. If that's 3, this is going to be 6, and then that means that this guy is going to be 3 root 3. All right. A lot of 3 root 3s. All right. I got a base of 6 here, which means that this whole thing right here has got to be 12. And if that's 3 and that's 3, that's going to be 6. So I've already got 12. minus 6, that's 6, minus the 4 that we have right there. That means this guy's got to be 2, because that's all that's left on this double 6 side, the hypotenuse on my 30, 60, 90 triangle. Also, we have 6. This whole side should be 6 root 3. And if that whole side was 6 root 3, but I have 2 root 3 up there already, imagine this. All right, think about it this way. I just have a group of root 3's. I got 6 of them in this group, and I'm taking away 2 of them. How many root 3's are left? 4 root 3's. It's just that simple, all right? It ain't that deep. So now you can kind of see how we have 4 root 3, 2 root 3. That's going to make up this entire leg of this triangle right here with 6, 6 root 3, and 12. What we are going to dive in a little bit to and explore is this triangle. I'm not going to do that right this second. I'm going to do that in the next set. But we're going to look at this triangle where we have this strange thing happen where no longer is that B side some root 3, but we can actually measure it. It's 3, 2, and 4. It's 9 right there. 3 root 3, and it looks like the hypotenuse is 6 root 3. So we're going to explore that one a little bit. That's going to be interesting, and we'll check that out a little bit later. Stopping for now.